Okay, so I'm about to start the recording. I'm gonna try and record the mouse button so that I can sync it up. Okay. So, for a course at university, I need to learn about a piece of software called the Z3 Solver, which is made by Microsoft. And it is basically, I'm just learning about this, right? So everything that I'm talking about, take it with a grain of salt, because I'm just learning about this. I might say wrong things. Okay, enough disclaimer. Oh, and also, I've noticed I need to work a bit on like how I record myself, because sometimes you can hear my mouth a lot. So if you're not into ASMR, I'm sorry. I'm gonna drink water, whatever. And I'm mostly making the video for myself anyway, so if you don't like it, don't watch it. Yeah, so Z3 is basically a layer on top of a good SAT solver. Yeah. So it's like a SAT solver that has more than only Boolean variables. And they call that an SMT solver. Then Z3 is you can interface it multiple ways. I think the most basic way to interface with it, or at least one way, is there is some like universal like domain-specific Lisp to describe problems to the SMT solver. I don't remember what it's called, but I don't think it's used that much for Z3, because all of the resources that I've found seem to be using the Python bindings, which might use that in the background. I don't know. And I learned about the Python bindings from this tutorial here. So you can copy the URL if you're interested. You can probably find it very easily. It's like one of the first resources that I found. Yeah, and I think this guy here, he's also the guy that works on Lean, which is like super cool. I don't know that much about it. It's his name is also Leonardo, but I don't know his last name. But like Lean is a super cool project in my opinion. Yeah. So Z3, okay. So this tutorial is quite good. I think I read most of it. I don't really remember. I think they go through solving a Sudoku puzzle. Well, yeah, here, Sudoku. All right, so I was thinking while reading this, like, yeah, I should also try and solve something so that I'm sure that I'm not just like parroting some example, right? I really want to understand this. So I thought I really like solving a certain kind of puzzle, which is called a KenKen. Or KenKen is like the generic name, I think. Wait, Kendoku? Oh no, KenKen is like the trademarked name. So yeah, KenKen puzzles, they're like a little bit similar to Sudokus in that in every row you cannot have duplicate elements, but they are on average, they're on average way smaller. Like the smallest ones that are fun to solve are 4x4. And instead of boxes that all have to be distinct, the constraints are labeled as like sums or products. So yeah, if you just look at it, you can probably understand what I mean, right? So the two elements in here, their quotient has to be 2. So 1 and 2 would go in there, 4 and 2 would go in there, but 1 and 3 is not allowed to go in there. And then every row and every column has to have all the numbers from 1 up to n, I guess, in this case 4, and they all have to be distinct. Okay, so that's basically what a KenKen is. And then I went through, I'll show you the source code in a minute. So I documented it in my notes. Yeah, computability theory. Wait, I should have prepared this better, I'm sorry. What? Oh no, it's not computability, it's automated reasoning, sorry. The course, my course that I'm following. Yeah, okay. So it's written in Dutch, so, and I'm not gonna publish my personal notes. So. But I mean, if anyone is interested, I show the source code, you can copy it. Yeah, so I tried solving the following KenKen that I found on Google Images, I think. Yeah, and the way, okay, what I came up with is I label everything. So the names of the variables, I don't know how they do it in the tutorial, but I thought I would do it as you do in that game. I don't know what it's called in English. That game where you attack the other person's ships. I think it's called Battleship or something. So that's how I labeled the variables in my example. And then so the idea is you introduce n squared. So n is the size of the puzzle, in this case 4, right? And then you do, then you create n squared variables where every variable is an integer. Every variable is an integer, so like a1 is an integer, and so is c3, and so on. So you're basically doing the Cartesian product. So there's n squared. Okay, I think you get it. It's not super complicated. And then you can just encode the constraints as sums. So it looks super easy at first, right? So I tried that. Okay, so here's my implementation. Yeah, it's super short. It looks like really easy, right? But this didn't work. And I think it's useful to document, for myself at least, the mistakes that I made, because that's how you learn, right? So I introduced all of these variables, which is already, I think you can probably do this in a better way, right? It's my first time using this, so yeah, if you have suggestions of how to do this in a proper way, like please tell me. I would be like happy to hear about it. But it's just my first attempt. So I did this. They're all integers. And then all of the constraints, I just straight up put them in like that, which seemed like the most straightforward thing. Oh yeah, and I didn't write this by hand. I wrote a little script that outputs this code. But yeah, okay, that's not super interesting. But then it solved it, kind of. But it came up with very funny things. Okay, so this dot, you can ignore that. That was just for the formatting in my Gameplike program. I used Krita probably for this. I don't remember. So it kind of came up with a solution, and it's actually funny to look at what it did, right? So it solved it in a very logical way, but I didn't put in enough constraints. So it's really, I think it's really beautiful to look at how this machinery just comes up with kind of the best solution. So it didn't do anything random for the ×4 case. It chose the most, I don't know how to describe this formally, but it kind of chose the most beautiful assignment of the variables, right? 1 × 4 × 1. And for 11, it just, for the sums, it just, the first element that it comes across, it just assigns that to the sum value and the rest at 0. Like, that is so beautiful. And for the product, it did the same thing. But okay, so the program obviously works, right? Z3 is not going to make a mistake. I didn't put in enough constraints, but I think the thing that it came up with is so beautiful. Okay, so what was the mistake? I needed to add more constraints. And I think, yeah, what I did here, again, the code is very ugly, I know, but it works. I think through being a developer, I worked as a developer for a while after my studies, after finishing my bachelor's, and it made me realize, like, yeah, a lot of stuff that we use in real life is very ugly, but it doesn't really matter. Sometimes it's okay for stuff to be very ugly as long as it works. Yeah, it's a pain in the ass to maintain, and over time you hope that you get rid of it, right? Or you improve on it. But that's like the difference between engineering and science. So yeah, in this case I did some hardcore engineering. It's a super ugly solution, but it works. So first of all, I think I did some more experiments. I tried adding more constraints, and then it started coming up with negative numbers and stuff. So I added the constraint that everything needs to be bigger than 0. And I think I should have also added, yeah, that's funny. Okay, I forgot what I wrote, but I added the constraint that everything needs to be bigger than 0. And I added the constraint that the numbers need to be distinct, right? Which is this. You can probably write it in a more elegant way. I probably wrote some code to like generate this. I didn't write it by hand, I'm not stupid. Wait, let me scroll up again. Oh, my keyboard is not working anymore. Yeah. Let's see. Yeah. So I thought about it for a bit, added these constraints. And then, wait, let's see what it came up with. Oh, wait, no, then it was right. Oh, that's actually, oh, no, okay. Yeah, then it came up with a solution again. And I didn't write it on a picture, so it's kind of hard to interpret, right? But I think, for example, yeah, it sometimes put in stuff that is larger than n, larger than the size of the puzzle. So that was obviously a constraint that I missed. And then what else did it do? Okay, I think that was the main thing. Wait, let's see what I wrote here. Okay. Okay, so whatever I wrote here, I don't really know. Let's see what I added. Oh, yeah. Here I added that the variables need to be smaller than n. And I think I also added a bunch of constraints that I didn't before. So the non-equals up here only say, these are only the rows, right? Look, so here on every line of inequalities, I only added the A's. But I never added anywhere that A1 cannot be equal to B1, I think, if I look at it quickly. Yeah. So I only added the distinctiveness of the rows, but I also needed to add the columns, right? And then I also needed to add the fact that the numbers need to be smaller than n, right? And I wrote some code to generate the code because I don't know how to do it properly yet. Work in progress. And I think, yeah, I wrote it down and it worked, which is super cool. Like if I had to write this, like a program that solves this in plain Python or something, like as you would in a programming competition, I haven't, like that is hard. I don't know. Then you have to like start doing searches and stuff. Like this is some amazing tech. I'm super impressed. And yeah, that was it. I wanted to, yeah. So I hope if you're learning Z3, you learned something. And I hope for myself, if I rewatch this, I can appreciate how bad I was and how much I've improved. So that was it. Thanks for watching.